Hello everyone. In this video, we are going to be discussing about the data preparation phase to model the data. So basically, here we would like to discuss the techniques and steps that is used or applied on the data before the data is modeled. So let us get into it one by one. So first we have partition the data. So here in partitioning the data, we divide our data into training data set and test data set. What is training data set and test data set? So training data set is basically the data set which we will use to train our model, and test data set upon which we are going to test our data model as how it is working or if it is working correctly or not. How we can do this in Python? So we can first see here we have pandas library. We have imported the pandas library as PD, and we have a sklearn library from which we have called the model selection module and imported the function train test split. It is a pre-made function which helps us to split the data set into two parts, that is training and test data sets. Let us run this one by one. So here we have imported these statements. Now we will read in our data. Here we have read in our data using the read CSV. If we want to see what is the data here, then we can see this is the shopping trends CSV which I had previously uploaded on my Google Drive here and uploaded here with the help of read CSV. Now going downwards, we have split the data set into training data set, that is trends train and trends test, using the trends test split. Here we have gave our data as parameter. We have implemented the test size and random state. Random state is basically the seed from where the partition will occur. We will run this and we will like to know how many rows and columns are there in our data set and how many rows and columns are in our new splitted training and test data set. So what we are going to do, we are using the shape. Again, the shape, as we had discussed in earlier videos, it is a method that is in the pandas library with data frame. So here data is basically a kind of data frame. If we run this, then see we have 3900 rows and 19 columns. This is the correct. Now we will see from this data how much data has been in training data set and test data set. So we have 2925 rows in our training data set and our test data set has 975 rows. If we want to see what tuples are in there, we are going to simply print the results like this. This is our training data set. It has all the columns, as well as we have downwards here the test data sets. It also has all the columns. Now sometimes there may be chances where there are imbalances in our data set. What kind of imbalances? We are going to see it here by an example. Suppose we are going to take a subscription status column from our data set. Say we are going to run this and use the value counts command to see how many values, means how many responses have no and how many responses have yes. So as we can see, the no's proportion is higher than yes. If we see it here from the different response variables, it's kind of balanced, and if we use it here, then it is also kind of balanced. But if we see the subscription status, we have the proportion of no higher than the proportion of yes. If we train our data model on this data set, there are chances of erroneous data models, that means wrong outputs, such kind of things. So it becomes necessary for us to balance our data set. How we can balance our data set? We can balance it by using the resampling techniques. And resampling is the process of sampling at random and replacement within the data set. Means we are going to just use the data set that we have previously. We are going to sample for yes, so we are going to use the records of yes and use this formula, that is rear plus x is equal to p records plus x. So rear means the rear part of variables and records mean total number of records, and p is basically the proportion. X is here the quantity, that means how many records we want to add on. So if we move downwards, here we are going to be resampling our data set using the log command like this. It will return all the output where the subscription status is yes, and this will be stored in to resample. Now we will see, so we are going to use our resample, means we are going to use the sample function and resample using the to resample the previous object and sample the data set. Now what is the n is equal to 126? So I had previously calculated the value of x, means how many records I need to add in the data set using this formula, and the value has came out to be 126, so I have put it down here. Moving forward, we will concat, means we will add the data set of, that means we are going to add these sample records into our main data set like this. See here we have added the records, means here the values has changed. This here I had used 30% proportion, means how many, means here the value of p here I had used 0.3, means I want 30% of records to have yes. So now moving forward, this is how we can balance our data set. Now we are going to see how we can make card trees using Python. So card trees are nothing but classification and regression trees. Before that, we need to discuss what is a decision tree. Decision tree is a flow chart like structure where each internal node represents a feature, each branch represents a decision rule, and each leaf node represents an outcome. Means basically we want to classify our records and we are going to be using a tree like structure. So let us see an example. Here this is a decision tree. We have a decision node where we are going to be implementing a split method, that optimal split or condition upon which the decision tree would be splitted into branches, and this is a decision node again, and the lowermost are called the leaf nodes. Go back to again here. So classification and regression trees method produces decision trees that are strictly binary, containing exactly 2 branches, and we will see how this will work here. Card basically recursively partitions the records on training data set into subsets of records. So we will see how this can be implemented using Python. First we have imported all the necessary libraries. We are going to use sklearn's tree module and import the decision tree classifier and plot tree. Now we have read in our data, and we are going to be encoding this data because decision tree class expects some kind of numerical values. So we are going to encode this data to get its dummy values. Now we have applied the train test split here again, and we are going to have the x train and y train variables, which are basically we're going to be used in the decision tree classifier to train our data set. Now here we have used decision tree classifier, and this is how we can make a decision tree. Here we are training our decision tree. If we want to plot this decision tree, this will look like this, something like this. This is our decision trees visualization. The next is C.50 tree using Python. C.5 is basically another decision tree, but here we are not restricted to the strict binary splits. We are going to be using the decision tree classifier again here, but here we have two criteria, that is entropy or gain index. Entropy basically means the information gain. Here we have max leaf nodes, means we have mentioned how many leaf nodes we want here, and we have fitted our data into the decision tree classifier, and the output will be returned into this object variable. If we it will give us result like this. So this is how a C5.0 decision tree visualization can be made. Moving forward, we have random forest. So random forest is like forest, that means a collection of trees. So it is an ensemble learning method, means we are ensembling the decision trees we got using the training data set, and all its output will be ensembled, and then suitable analysis would be made. So using the previous code only, we are going to be extending it for the random forest. We are using the ensemble module and importing the random forest classifier here, and using numpy as well. We will see where we are going to use it. Here we have implemented the random forest classifier. This is how its visualization would be done. Here we have added a font size attribute as well, so that our random forest would be visible clearly. See, this is how it's actually look like. So that is all for this video. Thank you. Evaluation.